Welcome to our workshop, Software Defining Network workshop. We have today 5 presenters, and we will try to give information about the software networks and new development, and about this new structure, especially in the Internet of Things, some new development in this field. And the first we have about the first. Let me tell you the order of presenter. Sorry. Okay. We have first Dr. Selvaraj, ST enabled Internet of Things. The second one is Dr. Saifullah, Introduction to the SDN. It is architecture with focus on distributed controllers, including emulators for SDN and the Mininet. And the third one is Dr. Comfort Olebara, Evaluation of Network Management, a Guide to Software-Defined Network. And the fourth presenter is Assist Professor Priya, Implementing SDN Tools and Techniques. And the last presentation is Dr. Pankaj, Dadheech, the current status, the future software-defined network. For this online seminar, the Sherry Ann Early, she is an intern from the University of West Indies. She is doing the master now in the leadership and technical vocational education. So she will coordinate the seminar with me. And so you can give some information about Dr. Selvaraj, Sherry.
Thank you for having me.
Presentation is Dr. Selvaraj.
Yes, sir.
Okay, thank you for having Dr. Imran. Are you hearing me?
Yes, we can hear you.
Okay, lovely.
You can give some information about Dr. Selvaraj?
Yes, thank you. Dr. Selvaraj is working as an associate professor in the university at the University Department of Information and Communication Technology, UDICT, UMGM University. He is the implementation of seed fund project entitled Biomass Estimation and Prediction using LIDAR and Google Earth Engine with special reference to MGM campus. He has the ability to work with international facility members in geoinformatics and IoT domains. He is in research collaboration made with Dr. James Gazam Abodo, forgive me of my pronunciation, Damascus University in Syria. He presently holds a PhD in remote sensing, geoformatics, National Institute at the from the National Institute of Technology, Trichy, Tamil Nadu, India. He also holds a MTech in remote sensing with a first-class honors from the College of Engineering, Gidi Anna University, Chennai, Tamil Nadu, India. He also holds a bachelor's in electrical and electronics engineering with a first-class honors from the Anjali Amal Michigan Engineer College. We now present you with Dr. Selvaraj. Dr.
Selvaraj?
Yes, ma'am. Yes.
You can share your screen?
Yes, sir. Yes, sir.
Thank you, Sherry. Thank you very much. You can start?
Yes, sir. Now audible, sir?
Yeah, I can. We can.
Thank you, sir. Thank you for your confirmations.
Okay. Yeah. So we have about 15-20 minutes for your presentation. Good luck.
Okay, sir. Okay, sir. Thank you very much, sir. So I will come here to the that webinar on the software-defined enabled IoT network. And my name is Selvaraj, Associate Professor in MG University. So when I say IoT, what I mean is simply if you take any device or if you take anything to be connected with internet, that is to be exactly what is in IoT. And when we talk about the industrial version like 1.0, 2.0, and 3.0 up to, so the devices, the contribution of the devices has been increasing, especially in industry 5.0. So what happened is that we are going to collaborate with machines like human being. So contribution of the human and contribution of the machine is going to have in industry 5.0. So here IoT is one of the domain which is very important. Everyone should learn about it because it is going to give a lot of contributions, and it is giving a lot of technologies, especially in the lot of sectors. Especially when we talk about the agriculture sectors, and already the AI technology is there, and also we are going to incorporate this IoT technology as well there. So I expect, recently I appraised lot of papers in the literature. It shows that we are expert thought that we are going to have millions of devices going to be connected with IoT. So basically, the IoT can be derived from MTM. So here in this slide, you can see lot of equipments like right, different kinds of devices to be connected, and car, and some here you can see some health sectors, and so many things are to be connected here. So that we can do a lot of minimize the human interruption. Sometimes when we talk about right in human oriented, sometimes very disadvantages also, because we are going to collaborate with human being now. So in industry 5.0 is concerned, so collaboration, for example, Alexa is there. In Alexa we are going to talk with some task with Alexa, and machines is also going to be contributed. So IoT basically contributed, I believe, from machine to machine communication. So machine to machine also is subset of IoT nowadays. Nowadays, machine to machine is subset of IoT, because in IoT we go beyond that. We are going to transfer the data, and we are going to transfer the information to the outside the world through the internet or cloud. So machine to machine is simply we are going to transfer the information from one machine to other machine. So here, the software defined is highly essential for shorten the data process. And also, when we talk about right, we go for that switches, and we go for devices physically we need, right? So when we go for the software defined, it will going to replace, because we are going to use software. I'm going to tell you that what are the cloud we are using in MG University, in our university. And as far as so Cisco is concerned, right? So digital technology going to impact and everything to be connected. Just now I said earlier that we are going to have millions of devices going to be connected. For example, so your home also going to be connected with, or in each devices in your home, like kitchen spot also to be connected with internet. In future, in around, I think I expect within 2035, we are going to have that all the devices to be connected, I expect. And addition to that, we are going for the generated data sets, because nowadays we are having lot of generation of the data sets. Vast amount of data going to be generated by using IoT. And also we are having like big data. So big data and IoT also coming. So generation of the data set is going to have abundance of the data. And automated nowadays also in IoT also projects with transferring data to the server like Google spreadsheet, graduating the PhD, that time network, and if you have the IoT, and because that time it has been initiating, so that is why. But nowadays we can do all the process to be automated. So in my field, even I don't want to go to field. Suppose we want to analyze the data, it's a possible by using software-defined network and IoT. So many things are there. And I'm showing here some notable list of IoT devices. And a smart thermostat is 0. We are going to have interaction of human being. So what I do is, when we talk about particularly with respect to the smart thermostat, in which the human intervention like that by using thermostat. For example, any human can make a schedule in the particular app. So through the app, we can make use of the thermostat. For example, tomorrow I'm going to conduct one program in the particular conference call. That time it's particular with respect to the schedule of the time, the thermostat has been initiated. So depending upon the time interval, I mean, before starting about the program, we can get some so temperatures we can adjust. So like this, so many devices are there, and doorbells and washing machine also, I said earlier, they're going to be connected with internet, and especially with respect to the irrigation agriculture system also very important. So many devices are there, so many IoT based devices are there. But initially what we do is that we make use of optical based sensor. So development of the sensor with respect to software defined also another important aspect. See, it is not easy to develop easily software defined network, because basically I'm going to integrate the software defined into IoT. So we need to have supported IoT devices in order to support with whatever we are using software defined network. Okay, for example, I'm going to make own software defined network. I'm going to connect with internet along with devices. So very crucial fact. That is, what I do is, so we got to go for proper integration of the sensor in order to support with software defined network. So these are the notable IoT devices. There are n number of devices are there. So you have to have a knowledge on the devices. And coming to the software defined network, with respect to the IoT, sorry. So with respect to the IoT, as I said earlier, it is not easy task, but in future it will be very easy task, because here we have to think about two parameters. One is that controlling the value, controlling the data, and traffic the data. So that is what we are going to see in the coming slides. And basically, we are going to design a own software in order to support the IoT devices. That is nothing but exactly what we mean by the software defined network. And also the software defined network to be connected with each devices. For example, when you talk about Ethernet, in traditionally what we use, we can make use of the Ethernet, and we are generating the IP address, and as soon as get IP addresses, we are transferring information to the particular IP address. So same thing we are going to have here, but here we are going to have software defined network, and it is going to be generated the IP address also possible. Otherwise, there are a number of clouds also there, like ThinkSpeak is there, and Google Spreadsheet, Google Cloud also there, and Microsoft integration is also very important. And if you go for commercials like Microsoft, and if you go for that Amazon also, they have n number of cloud service there. So software defined network also, we can make as a own server sometimes. We can make it as own server, and the device to be connected and to be transferred to the software. So in my place, I can make use of the software defined network. I can control whatever I want with the devices. So that is most important. And also I have done so many things regarding the software network with respect to IoT project, and also applied a lot of project with getting patent granted. So that is what I think there are a lot of gap is there. So we got to understand basically what is the software network, and we got to apply your endeavors in this area. So that is most important. So when we talk about software defined network, it is going to be simplifies the process. So that is also very important thing. It is simplifies the process. Because suppose if you make use of some open source based software, so very easy to have to make use of that that open source software. It has some details. We have to give some MEAC address, media access control, with respect to the software defined network, and you have to give the IP addresses also, static address, dynamic address. So everything to be defined in terms of software. And I said earlier, there are two factors there. One is control plan and data plane. So first of all, you have to understand what do you mean by the control plan and data plane. Because the software defined network, I said earlier, it is going to apply in each devices. For example, if you make use of n number of router, and when we talk about conventionally, what we did is we make use of router. In router, I connected IoT devices with router. Okay, after connecting IoT devices with router, we can generate the IP address. And as said earlier, we can transfer the data, whatever we are going to do real-time implementation, that is going to be transferred, right? So here, what I do is, when we talk about conventional methods, so this kind of software defined is not there. But here in 2020, in 2025, we are going to make use of the software defined network to be each router, because it is going to regulate in terms of control plan and data plane. So I given easiest to understand when you talk about, because I'm basically in the remote sensing background, I may make use of GPS devices and collecting a lot of samples from particular locations. Okay, so I am taking that examples to understand easily. So that is called like GPS global position system, and it has some waypoints. How many waypoints are there? How many points we are going to collect? I mean, samples number of points. And we are going to make schedule of the plant from one place to other place. I mean, suppose if there is any place to obstacles, we can go for in another alternative way to destination. So we are going to fix destinations and your starting place. Okay, so we are going to make a ways, points and roads. You go to delineate. So that is what the control plan, because I want to achieve, I want to go to that particular destination place. So that is what actually happening in the software defined network. The software defined network is going to transfer your data from IoT devices to the destination points. Okay, so another important part is the data plane. So data planes, basically it is going to control the data. So like suppose if there is any volume of the data, I said now that is it is going to generate vast amount of data. When we talk about IoT devices, even we can generate 11 days, 24 hours, it is going to generate data full time. So that it has a larger number of data is going to have, so that the traffic volume is will be there. So you have to control the data. So this plan will be using for to regulate the data itself. So this is what we'll be talking in later in the coming slides will detailing. So basically you should have some knowledge on the IoT networking, and you have to knowledge on the IoT and as well as networking. And as per the data plan is concerned, it is considered as a switches. Basically in network, what do we have? We are going to make different layers, like we know, right? Layer 1, layer 2, layer 3. I think in our university, I think we have n number of layers, first layers, and in third layer, it is minimized. So we are having like 25 layers to be connected with cloud services. I mean, we are not using the any open source, and we are using the commercials based cloud service only. And we have to minimize the switches also. So sometimes it is inevitable to use the hardware. See, exactly, we cannot go for replacing the software defined. Suppose what I am saying is this, we need to transfer the data as per the IoT is concerned. IoT is concerned, we need to have transfer information. So the particular devices has to be implemented the antenna. So through the antenna, the all the signals will be transferred from one place to other place. So sometimes it is highly necessary, but you have to minimize. That is what I am telling that. Okay, you have to minimize the hardware devices and maximize the software utilization, so that we can reduce the cost effective. So we can also make use of affordable projects. Okay, so you have to know what do you mean by the control plan and the data plane. Simply, I'm saying that it is you have to make a schedule of that data transfer from one place to other place, and how we are going to data transfer from one place to other place, like in terms of packets, networking packet through the router or switches. Here, the router or switches going to act as in software defined network as switches. I mean, like software switches only. Okay, so I'm showing this some slides. Here, when you talk about that SDR enabled IoT network, so we are going to have some important component. I said earlier that IoT device is very important. You have to development of the IoT devices, and SDR hardware. Sometimes I said earlier that hardware is also necessary to transfer the information. When we talk about antenna, the antenna has to be designed. Okay, so after that we can go for that SDN control, that is software defined controller. The software defined controller is going to apply to each router. Suppose we are having 4 router, the SDN, that is software defined, will be going to connected with SDN as well. So sometimes we need a base station also, but it is optional. Sometimes it is not necessary to go for a base station, because it is depending upon your scalability, how many sensors are going to integrate your projects, and that is range of the distance of the from one place to other place, the way of transferring data. So these are the factors to be kept in mind to before designing these factors. But I'm telling you that these are the factors very much important for our software-based enabled network. So these are the proposals even under process, like we are going to make a data sensor by using software defined based data sensor, and we are going to implement the software based controller for making a smart canvas server. And sometimes, as I said, we need a hardware also, like IoT devices. I'm going to connect with classroom sensor, because as per university consent, so since a very big universities, and we are having a lot of rooms, and we are having a lot of classroom and a lot of conference rooms, and so, and also we are having 65 acres of the land. So handling this kind of things is very difficult in conventional method. So that is why we approached with the university, and we are going to have that proposal for software defined network for smart university. Like we are going to have smart device university integrated into cloud. So everything to be integrated in the cloud, and we go for that analysis and visualizations, all those things be done. So these are the data center in universities, and this is in the picture you can see the server. I mean, it is a data 3 layers. In data 3 layers, I think we are having 25 switches, and in left side you can see some switches and integration of the switches in the board, and some security also there. So this is a very important room, because we are having to handle all those data here only. So sometimes with security components also very important to in software defined. Sometimes the software defined network has some advantages, is that security is very important, data security and implementation. So we need to have some contribution slot needed to integrate into software defined network in order to secure the data. And as I said earlier that we are using the Aruba Central. When we talk about Aruba Central, what I mean is that it is a software defined network. It is exactly commercial software, and we are having like 25 switch, I said earlier, that to be connected and monitor. And also I said earlier that wherever I go, I can connect with this, make use of the cloud. I can access all the switches. And also we can visualize the data utilization, and even I can access the particular IP address, even I can disable, enable, and I can, whatever the information going on and everything to be defined in software confined matter. You would understand, in software confined matter, everything to be controlled. So that I'm saying that it's a very effective technology is going to replace in IoT. And also a lot of, software defined have some IoT integration. So in this way, this HP, like Aruba is belong to the HP hardware. Okay, so here Aruba Central is going to integrate the IoT operation as well, IoT application as well. Here we are going to have the IoT devices said earlier, right? Smart campus to be connected. All the sensor integrated in the entire campus to be connected with these clouds. I mean, in terms of switch. And in outside, we are having lot of switches, switches.
Last 2-3 minutes.
Okay, sir. Okay, so I'll experience. So we are having out of lot of layers ones also there, like switches. So in a switches one, I mean, when we talk about data one, layer one, we are going to have a lot of physical devices also, because sometimes the need a sensor is to be in physically, right? So sometimes it's not possible to have software based sensor, but it is sometimes it's inevitable. So n number of devices to be in layer, but after layer 2 and after layer 3, you go to shorten the layers and to be connected with software defined network. Okay, and you can see here that I said, all the switches to be connected here. I think we are having data 3, like 25 layers are there, different fielding, and we can see that current configuring status, utilization of the data, address, whether it is on, off, everything to be there. No need to go that particular page, because suppose we want to go that particular page, right? We have to go for in manual. So manual interpretation is option here, and we can have like total number of clients is to be connected as per this yesterday is concerned. I think more than number of devices to be connected in client. Okay, and access point also there in through Wi-Fi also. So Wi-Fi access point also to be connected with software defined, and all the Ethernet also to be interconnected, everything to be. And application also, right? So what, how many applications are there? And also I said, no, IoT is going to, it's one of the application. Suppose you are doing your own server, Okay, then server also to be monitored here. Okay, so how you are doing that, what are the data is there, whether your device is on off, whether your device is performing or not. Okay, it is like an application. If you made that application to be connected with software defined, as an administrator, I can control your devices also, 10 on 10 up. Okay. So Aruba is, I said earlier that it's a software defined network. It's very powerful. It has a lot of facilities, lot of features are there. You have to utilize this also. And through the Aruba, we can make it a central cloud integrated in our institute or anywhere. And it's performing both control plan and other plan also performing well. And every times we don't get any disturbance software defined network. That is the most advantages. When you compare to the physical, like it's very difficult to go there and you have to check it up the switches and everything. It's sometimes very hectic, right? But software defined network will give the solution for us what kind of problem, because basically we are going to write a program, programmed one, that is the most important. So since it's a programmed one, we'll be getting error status also. So based on the error stages, we can go for the troubleshooting and we can solve the problem at the easiest manner. Okay, so the Aruba centrals with IoT device management, it's have a lot of scalability. In this slide you can see, and analytics and data analysis also there. So data analytics also there, but if you go for conventional methods, not possible. Again, because we have to extract the data, analyze the data. After that, you can go for that machine learning algorithm. But here we can integrate the machine learning algorithm also. So everything to be integrated in the single plane. Okay. Then another important is automation. I talked about already that. It is going to replace the software defined network for automation, and software control platforms such as Open Daylight. It's very powerful, and ROA, that is Python based programming languages. You can make use of that, and you got to be some micro Python languages, like you have to expert into some library. So somewhat is initially it will be very difficult to write a program, but later on it is very easy to access in software defined network. Okay. This is a common procedures, right? You have to initialize the SD1 controller, software network controller. You have to initialize. I said right now. I said just now that Open Daylight. You have to initialize the Open Daylight or ROIU. Okay, you have to initialize, and you have to initialize all the devices information like media access controls and Ethernet information. Everything to be initialized. And you have to define the flow rules. That that is what I said earlier. That you have to define that destination IP address and starting your IP address. I mean, it is dynamically or generated or statically generated. So that is what exactly what you mean with flow rules. And the sensor data collection. It's a very important thing in IoT with respect to the software defined network. And that network handling is done automatically. That is what I am saying there. See, listen, the software defined network is going to control automatically and rectify itself if there is any problem in the data packet handling. It's handling automatically, and it is also like data processing said earlier that, and network monitoring as is management and error handling, because we need to have we have to become a good health programmer, because it is a new one. So you have to give error handling stage also, because we are going to sometimes the client may not be knowing about it, right? So in order to understand the error stage by the users, you have to give some error handling programming to be done. And security consideration, I said no, because software defined network is going to transfer the data in wireless. So without wire, without conductor, so that the security factor is there. It's also you have to take care of that, and testing validations and documented maintenance. When you talk about documentation, what I mean is that you have to take care of the documentation updations with respect to the Open Daylight night processor. I mean, Open Daylight software and other open source SDN. So with respect to this, my presentation, I conclude that the integration of the software defined network and IoT, it is going to offer larger number of benefits, and especially with respect to the scalability and number of devices, like number of switches to be connected. Even I expect, that thousands of switches also to be connected with layer 3. As per this, I used that now, that is open source, that is called Open Daylight. Okay, we can connect that also. We can make use of thousands of that integration of the devices along with switches to be connected. So basically, we need to have some program knowledge on it. So that is what one of the drawback that. After that, we can make use of centralized server as a data center based on the software defined network. and you can perform whatever the operation. It's not a matter. We can do n number of performance of the operations can be transferred from one place to other place by using software-defined network effectively with respect to my experience. So with these conclusions, I conclude my presentations. Thanks to the Krishnan sir for giving this opportunity to expose my knowledge and transfer my work to the audience. Thank you very much.
Thank you, Dr. Selvaraj.
Yes,
Very nice presentations.
yes, sir.
So my main concern, what you make the more quicker. I mean, you can connect many devices more quicker
Yes,
and
sir.
more centralized. But
Yes, sir.
my main questions: what make you superior your design than the others? Which challenge the people that they can face? I think having that much data in the one place and controlled by one center can be problem or not?
Yes, sir. It's a problem because we are going to integrate all the smart devices with this software-defined network. So in which I need to access the particular media access control, because we need to have the unique ID for different devices. So integration of that MESU to the software, because I need to declare each MESC address of the devices. So that is very difficult, but we need some manpower to implement. But once implemented in software domain, after that accessing is very easy.
Okay, Sherry?
Yes. Do we have any questions from the audience for Doctor? Any questions? You can type it in the chat or you can raise your hand and we will get that question. Is that a question? All right, so I'm not seeing any in the chat, so Doc, you can go.
Okay, thank you. Our second presenter is Dr. Saifullah. He will introduce the SDN, its architecture with focus on distributed controllers, including emulator for SDN and Mininet. So you can give some information about him, Sherry, bio.
Okay, thank you. M A Saifullah obtained his Master's of Research in CSE from IIT Madras and PhD from AUC. He published multiple papers in reputed international journals such as IEEE, Springer, and presented multiple 6 papers in reputed international conferences. He worked in R&D division of top software organization, whereas the last software R&D job was in Cisco Systems in Bangalore. He received a couple of patent submission award, and also he received the Cisco Star Award. He obtained a gold medal for academic excellence. Dr. Saifullah currently working as an assistant professor at the University of Hyderabad, where he guided multiple PhD students. His research is in areas such as network traffic analysis, data center product, network management, SDN, NDN, and quantum network. Dr. Saifullah is well trained or is an expert to speaking to us about software-defined networking. Dr. Saifullah?
Yeah, thanks to Sherry for the introduction and also Professor Imran Aslan.
You're welcome, sir.
Yeah, and also thanks a lot to the WRW World Resources webinar, Dr. Krishnan Umachandran, for inviting me to this workshop. Is my voice audible?
It is, sir.
Yes.
Thank you. Yeah, the outline of my talk is I'll start with the introduction and then go into the limitations of traditional networks. Why do we need SDN? and what SDN gives, the benefits of SDN, and then the architecture of SDN. After that, I'll present the internals of SDN switches, then talk about open flow protocol, and a brief introduction about the distributed controllers in SDN. And then I'll explain little about Mininet emulator, and conclusion and references follows. Yes, already introduced, the SDN technology can create more efficient and centralized networking management so that it can reduce the costs. Important thing is with SDN, the network can direct traffic without relying on the hardware to make the decision. That's what the name itself is self-explanatory, that software-defined network. I mean, it actually does not require hardware to make the decision. So that is the important thing. The evolving network requirements, today we have a lot of demand. The cloud computing is creating a lot of network resources, requirements, big data, huge data sets are analyzed, mobile traffic, so many mobile devices, Internet of Things, millions or billions of things are being connected on internet. And not only this, the network transmission technology, the if we see the speed of Ethernet, 10 Mbps to 100 Mbps, it has gone to gigs, 1 gig, 2 gig. The mobile speeds, 4 gig, 5 gig, 6 gig. So it's growing a lot. Not only the network transmission speed, the network applications also, firewalls, IDS, IPS, or the load balancer, their performance is also growing a lot. So because of all this, the traffic patterns are becoming very complex. So we need a way to efficiently manage these traffic requirements. So the quality of service requirements, as we know, the measurable end-to-end performance properties, they are called the quality of service. So these are the guaranteed in advance by a SLA, service level agreement between the user and the service provider. Some of the POS parameters are throughput, delay, packet jitter, error state, packet loss, priority, availability, security. So not only the QoS, QoE is also a requirement, quality of experience. The quality of experience is a subjective measure of performance as reported by the user, not by the tool. This is important, particularly when dealing with multimedia applications and multimedia content delivery. So these are in addition to the QoS. QoS is the measurable units which can be measured by the tool, but QoE is by the person, a human being. So like we can see here in the end, the categories of factors and features that can be included in QoE are perceptual measurement, psychological, interactive, how good is the application. So these are actually expanding. So the QoS and QoE requirements imposed on the network are expanding. So that's why the traffic load must be handled in an increasingly sophisticated and agile fashion. So, but the existing, that is the current networks, are traditional networks. The traditional networks are current networks, meaning IPv4 and IPv6. These architectures are not adequate because they have limitations. Routing is based on only destination address, mean IPv4 and IPv6. This is one of the important the problematic limitation. So it is more distributed and autonomous control. There is no centralized procedure. So the Open Networking Foundation, there is a group which actually standardizes the software-defined technologies and software-defined standards. It states there are 4 limitations of traditional networks, traditional network architectures, that is IPv4 and IPv6. So first is the static and complex architecture. Static and complex architecture, this is the limitation of the existing network, that is IPv4 and v6. If we have to do any configuration, we have to do it manually because the different protocols and different vendors have different architectures. So,
Dr. Saifullah, you are on the same screen. Can you?
oh, is
You
it
are on
not?
this-
Is it not
Yeah,
going?
no. Maybe you make the presentation, open presentation, because we see also the first screen.
Oh, is it? Oh, yeah. For me, it is moving. Is it not? Okay.
No, not going. Now it's going. Yes, we are six slide.
Yeah. Is it moving now?
Yes, moving. Thank you.
Yes. Thanks for informing me. So, is the slide with the heading limitations visible now?
Yes, it's okay. It's good. You can continue, doctor.
Thank you. So the static and complex architecture, inconsistent policies because the different devices are from different configurations or from the different protocols. So network-wide policy requires a lot of effort and inability to scale because of this static and complex architecture. To add a new device, that is a difficult task. And vendor dependence, as already said, the different vendors like Cisco devices have their own operating system, their own protocols, their own way of configuration. Juniper has its own, IBM, 3Com, Broadcom. So different vendors have their own way of handling the devices, starting from the operating system or the configuration or their own proprietary protocols also. So these are the limitations of the existing networks related to the growing requirements of traffic management. We can actually see diagrammatically here. So this is a network diagram with the existing switches. So these switches are connected, but the issue with the existing network, as already said, all the applications or the operating system, specialized packet forwarding hardware, everything is in each device. Is the slide 9 visible? I'm just rechecking because
Yes, doctor.
okay,
Yes.
Thank you. So you can see here the network device, the existing network device has everything in each box. So that is then complex stuff. You can see the applications, operating system, and the packet forwarding hardware as it is everything in the same box or same device. That is the complexity. So the number of lines of code related to the operating system and the features are millions. And when it comes to the hardware, it is billions of gates. So complex functions like OSP of the routing, BGP, multicast, differentiated services, traffic engineering, network address translation, and the firewall functionality, all these are in each box. So if there is any dynamic requirement, it requires a lot of effort to change these things. So that is the complexity of the existing network devices. So what is how we can solve it? This is the idea of softwareization, that is the software-defined networks. So how do we make an OS, public open OS for networks? So as already explained, each box has everything in it. So can we remove the OS into a central place instead of keeping it in every box or every network device. So can we take out the that OS is called network operating system. So after that, making these applications also on top of it. So basically, each device needs to be simple enough so that it does the simplistic functionality, that is the simple packet forwarding hardware, so that the device is simpler. I mean, the changes can be done in the software itself. The network operating system, which is shown in the red color here, it is in a central place and it is in software. I mean, in the commodity server, like the general, our own Linux or Windows servers, Linux server. So that the instructions are given from the controller, the device which holds the operating system is called controller. So that can populate the information into the switches, what they need to do, so that it becomes simpler. So that is the idea behind softwareization. So even in the protocols also, instead of the distributed way talking to each device, so in the software-defined networks, it is in the central way that protocols are actually given by the network operating system, which is in a central place. So the three things: one is the central place, another is the separation, third is the standardization, open. It is not proprietary to any vendor. So it is very public, open, standardized. So as already shown in this slide, the important functionality or the important task done by the software-defined networks is the separation of control plane and data plane. Data plane is where the packet forwarding happens. Control plane is the actual functionality, that is the configuration or the routing or other than the packet forwarding, whatever functionality is there. So that comes into the control plane. So in software-defined networks, the control plane and data plane are separated. Data plane holds only the switches and control plane consists of controllers. So as we have seen different controllers, there are dozens of controllers. Open Daylight is written in Java, RIU is in Python, Nox is there, Pox is there. So not only couple of dozens or even more than couple of dozens controllers are available in major programming languages. So if we see diagrammatically, the existing switches as shown already, it has everything into the same switch, whereas the software-defined approach is SDN approach is controller is going to take the brain position, meaning everything complex or the operating system, routing and other functionality is taken care by the controller, which is there in the software, which can be easily modified or extended. And only that information is sent to the switch, so that switch does only the forwarding, meaning depending on the given instruction, that is entries populated in the table, that actually forwards according to that instruction or the table. So this is the existing network and this is the SDN network. And along with the SDN, there is a other concept called NFV, network function virtualization. In network function virtualization, each network function, that is the network device, can be virtualized, like the virtual computing, which has the hypervisor on top of it, VM1, VM2, virtual machine 1. So in the virtual machine 1, it can run its own operating system and also the network functionality. For example, switch. So the switch, instead of the hardware, it can be softwareized. It can run in the virtual mode, that is the NFV. So it can be a switch, or it can be a router, it can be a firewall, it can be IDS, IPS, or it can be a load balancer or other network application. So this NFV is an independent concept, but it is complementary to the SDN. So SDN is complementary to the NFV. So in the other way, as already explained, in the present data center, we have the computing virtualization, that is the same processor at the same time can run Windows operating system, Linux operating system, Mac OS. That's what the virtualization we know already. Different applications run on top of it. So the hypervisor, so VM. Similarly, the network virtualization is in the switching hardware. We have different controllers, SDN controller, proprietary, or it may be a open source because Cisco has its own controller, or different companies have. So applications run on top of it. So that is what the modern approach to computing and networking. So the this is the modern networking schema, where to implement the QoE and QoS, as already explained in the previous slides. So the SDN, software-defined networking, and NFV, network function virtualizations, are helping so that the network devices can meet the required QoE and QoS requirements. So as explained, the SDN gives, one is the centralization, another is the softwareization, third is the openness, the very public protocols. So because of that, it gives the benefits like centralized network provisioning, easily understood, comprehensive infrastructure management is possible, augmented automation, because the functionalities in the software, adding the automation is easier. Enhanced security, because security functionality can be added in the software easier. Reduced operating costs, reduced hardware management and costs, and as it supports the softwareization, cloud-ready infrastructure is also becomes easier.
Sir, Doctor, may you speed up? We have a shortage of time.
Okay, yeah. So the architecture of the SDN is 3 layers. The bottom layer is the data link layer, the data plane. So the virtualized switches and the physical switches comes into this plane. And the middle layer is the control plane, where controllers are placed into this. And the top layer is the network applications layer, where the network applications, like as already explained, firewalls, IDS, IPS, load balancers, are the network applications come here. The northbound API, that is the communication between the third plane, that is the application plane, and the middle plane, that is the control plane, is using the northbound API, REST API, that is representational state transfer, like HTTP. And the southbound API, this is very critical. The communication between the controller and the switches happen using the southbound API. The example is the OpenFlow. It is the most 99% is used by the OpenFlow protocol, which is the very standardized and public. So this is the internals of the switch. The switch needs to have this much only, nothing more than this. So it has the incoming this port. So the incoming port, incoming queue, outgoing queue, and the forwarding tables. This is the heart of the switch. Very simple. Forwarding tables. These tables I'll explain in the coming slides. So it has an understanding of the OpenFlow PDUs, protocol data units. And if we see from the network diagram, SDN controllers, so they run the OpenFlow protocol. So the solid line is the OpenFlow protocol communication to the switches. These green are the OpenFlow switches, and the servers, PCs, or the any user devices are connected to the switches. So like this, the SDN works. So the controllers sends the information, the instructions to the OpenFlow switches, and switches actually takes care of the forwarding of the packets. And little more details, like we talked about the tables. Tables are 3 types of tables. And flow table, this is the one which is the very critical table. And group table, as the name is self-explanatory, it applies to the group of traffic, we'll see. And there is another meter table also, which can actually count the number of different traffics. So a flow table needs to have these columns. Necessarily, it needs to have the match fields. As we said, in the existing networks, the matching is done only using the destination address, but in software-defined networks, matching fields are done using many fields, or even we can add our own criteria. So that much flexible. So by default, these are the fields available in the match field. Ingress meaning incoming port, outgoing port, Ethernet source address, Ethernet destination address, Ethernet type, IP port, IPv4 source address, IPv4 destination address. So likewise, it has many criteria which can be matched. So the priority, if it matches among the other entries, counters, there are different counters are there. Instructions whether to send it to the other flow table or to send it to which outgoing interface instructions, what to do and matching this incoming packet for this entry. So timeouts. So after how much timeout this entry needs to be removed, other cookies and flags. So these entries are populated from the controller to the switch, so that if it matches, then it takes the instruction. But if it doesn't match, it sends a packet in message from the switch to the controller, and controller sends the packet out message. So this is about the open flow protocol. As I already said, open flow protocol runs on top of TLS. That is the transport layer security, as we know already in the TCP/IP. So it has policy to send the entries, add, update, delete actions into the flow entries. But the thing is, a single controller cannot communicate with all the switches if it is a big network. So the problem is a single controller cannot handle. So because of that, that may be that may create a low responsiveness, or it may have a scalability problem, because 50 switches it may handle. But if an organization has 500 switches, then it's a difficult task. And the reliability also, if as it is in a single controller, if it fails, then it's a problem. So that's why having multiple controllers is a required task for the software-defined networks. So, but there are different ways of configuring this multiple controllers. Distributed architecture, like flat design, the controller can be within that area, those SDN domain, but there may be a hierarchical way of adding the controllers. The multi-controller, there may be a root controller that has the other controllers. Those controllers will be connected to the switches. So the flat design or hierarchical design, there are a couple of ways of configuring the multiple controllers. But the multi-controller solves the problem of the single controller scalability, but it creates other problems like the multi-controller scalability, how to add the multiple controllers, or even the consistency among the controllers, or the reliability and the load balancing. Because a controller may have so much of load, but the other controller may have very less. So that actually creates the problem in the performance of the network. So that is also a problem. So these are some of the problems of the distributed controllers. And this is about the Mininet. This is the emulator, as the emulator name. This is not a simulator. Emulator meaning it gives the realistic virtual network, meaning anything realistic, whatever you run, that can be run on the Mininet in a virtualized way. So I will introduce some of the important a little about the Mininet. Mininet can be installed using this command, apt-get install Mininet. And when you run it, this is the root or the super user mode. So, but if you can run using the sudo also. So once it is installed successfully, when you give MN, that is mininet, it will tell creating the network, adding controller, adding host, H1, H2. These are all very default. S1 is the switch, H1, H2 are host, C is the controller. It will start the command like CLI. So this is mini-edit, the graphical tool. So because without having the device, it's difficult to do the experiments. That's why mininet is very much required. Mininet is the emulator used for the SDN experiments. So nodes will give what are the nodes available. As already said, S is for switches, H for hosts, and C for controllers. If you give the net command, it will show the network. We will see some of the commands also. Dump, it will dump all the devices with its IP addresses also. And we can ping from one device to the other ping, like H1 ping H2. It will tell you whether it is pingable, reachable or not. So those commands, whatever I said here, those outputs are there. Network means it will say which host is connected to which interface of the switch. And dump will say the devices available with the IP addresses. And H1 ping, how the ping is going. So other commands like if we want to see the interface config, if config command, we can run all the commands, Linux commands run in the mininet. So that's why it is emulator. So ping all will pings the devices. And there are different topologies available in the mininet. So MN minus topo, because this topo is the topology, linear, each switch will be connected to a device, H1 host. So if we say 3, meaning 3 switches and 3 devices connected. This is the graphical description, and this is the command line. And other topologies are available. Tree topology. So switches are connected like this, and in the end, hosts are connected. So when we say sudo mn minus topo tree 3, it will start with a 3-layer tree. So it will say all the connections, and it will start the devices. So these are some of my publications in the area of software-defined networks. And these are the references related to this presentation. There is a paper on the mininet also, which gives a lot of description on the mininet.
Thank you. Thank you, doctor.
Yeah, if there are any questions, I will be happy to answer.
Do we have any questions for Dr. Saifullah? You can raise your hand or you can type it in the chat.
I mean, having too many controllers, I think will make the system more effective, Dr. Saifullah.
Yes, sir. I mean, yeah, it makes effective, but many controllers have their own issues also, like the load balancing, as I said. One controller may be overloaded, another controller may be underloaded. So those things also needs to be taken care.
Yeah. I mean, maybe some hierarchy problems, but I think seems effective.
Right.
No questions?
No question, doctor.
Okay, thank you very much,
Dr.
Dr. Saifullah. Our third presenter is Dr. Comfort Olebara. So she will present Evaluation of Network Management, a guide to software-defined networks. Doctor, can you hear me, Dr. Comfort? No, I think she's not here, maybe. So we go to the fourth presenter, Assist Professor Priya. Are you here? Priya?
Yeah, I'm here. I'm here.
Okay. Okay, you can share your
Just
screen.
give me 1 minute so that I can wrap up.
Okay, share. You can give a short bio about Priya.
Assistant Professor Priya holds a Master's of Engineering, degree in Computer Science and Engineering, and serves as a full-time assistant professor at Bannari, Amman Institute of Technology, She specializes in blockchain technology and is responsible for overseeing the blockchain technology special laboratory. In addition to blockchain development, she also manages Docker desktop, among other responsibilities. Professor Priya is well versatile in presenting on our topic this morning. Priya, Professor, you can go.
Yeah, just setting it right. Can you hear me?
We're hearing you.
Yeah, thank you. Thank you, Sherry, for the wonderful introduction. And thank you, Mr. Imran, Aslan, for your welcome. Yeah.
You are welcome.
Yes. So I am here
You're
to
welcome,
present.
Bob.
Yeah, I'm here to present something with respect to software-defined network and what are the different tools and techniques that can be used for implementing SDN, wherein the previous two experts who spoke about SDN was actually had given a very brief in detail insight of what is SDN. So let me throw my knowledge on how tools and techniques are useful in implementing this SDN, software defined network. So basically implementing tools and techniques for software defined network, this actually involves leveraging a variety of technologies, a number of protocols and different methodologies to enable centralized control, even programmability and automated network management. So in detail, we'll see what are the different tools and techniques that will help us in implementing SDN implementation. So it's simply this SDN controllers, open flow protocol, network virtualization are different. There will be a number of different tools which we'll be discussing on. So about those things we'll see now. So in introduction to SDN, in simple terms, it's actually a networking architecture that helps to make networks more flexible, scalable, and easier to manage by separating different planes to different categories. Say control plane from data plane and sort of. Okay. So let's explore how SDN addresses from my point of view. So it is actually centralized control. In traditional networking, a network device make their own decision about where to send data and from where it has to be received. So in SDN, the control plane is centralized, meaning that central controller has a global view of network and makes decision about how data flow through the network. So this centralized control allows more efficient management and optimization of the network resources. So what is flexibility and agility is it enables the organization to quickly adapt to change network requirements. See, by separating the control panel plane from this data plane, so SDN allows for dynamic reconfiguration of network behavior through software, providing the flexibility to respond rapidly to changing business needs and application requirements. Now, enhanced management is, it simplifies network management by providing a centralized point of control. This also allows for easier configuration, monitoring, and troubleshooting of network devices. So additionally, automations can leverage to streamline routine management tasks, like it helps to improve operational efficiency. And this control plane and data plane was already discussed. So about this greater flexibility and scalability, this is helping the scalability by allowing network administrators to programmatically define network behavior. This means that the network can easily adapt to accommodate new services, applications, and traffic patterns without requiring any manual reconfiguration of individual network devices. I hope it's clear. So about independent management, this SDN allows for independent management of network components. Network administrators can manage the network as a whole rather than having to configure and manage each individual network device separately. So overall, SDN provides a powerful framework for addressing the evolving needs of modern networks, offering centralized control, flexibility, and enhanced management separation of controls. And I mean, those sort of great scalability and independent management can be achieved. So the benefits of SDN is it helps us to improve network agility and responsiveness by quickly adapting to changing business needs by dynamically adjusting network configuration through centralized control. So this agility allows for rapid deployment of new services and applications, as well as the ability to respond to shift traffic patterns and demands in real time. So about increased network visibility and programmability, this enhances the visibility into network traffic and performance through centralized management, monitoring and mentoring for different analytics as well. So this visibility allows for better troubleshooting, optimizing, and security analysis. Programmability enables the automation of network tasks. So it is like we separate here into visibility and programmability. Visibility will help us to troubleshoot the problems and optimize, and security analysis is done through visibility. But in case of programmability, this enables the automation of network tasks, making it easier to implement new policies and services across the network. About this cost saving is by decoupling the control plane from the data plane and using commodity hardware, SDN can potentially reduce capital and operational expenses. So central management and automation also lead to operational cost saving by streamlining networking, provisioning, configuration, and maintenance. So operational efficiency helps to manage by providing a centralized view and control of the entire network. This streamlinedness and the administrative task reduces manual configuration errors and allows for more efficient resource utilization. So additionally, the programmability of SDN facilities, the implementation of consistent network policies, and also configurations across the entire infrastructure. About the vendor flexibility, it actually promotes different vendors by allowing organization to choose hardware and software components from different vendors that best suits for their own specific needs. This reduces vendor lock-in and enables organization to leverage the latest innovation and technology in the market without being tied to a single vendor ecosystem. Okay, so the key components of SDN architecture was control plane, data plane, southbound plane, and northbound plane APIs. Wherein the planes are, we have discussed about these planes and all. The forward plane that we call it as data plane, the forwarding plane is actually responsible for actual forwarding of network traffic. It actually consists of network devices like switches, routers, and other forwarding devices. Okay, so in data plane, packets are forwarded based on instruction received from control plane. So it does not make any decision by itself about the packet forwarding, and or it does not actually rely on, I mean, it actually relies on control plane for the instructions. Wherein in control plane is where the intelligence of the network resides. It is actually responsible for making decisions about how the traffic should be forwarded. So these are the basic of control plane and data plane. Now about the application planes, management plane and all, it is actually helping us to configure, monitor, and manage the different network devices. that plays a crucial roles in orchestrating and coordinating the various components of network, which helps us to enable or ensure that they operate in cohesive manner. So about the south plane and southbound plane and northbound plane APIs, all these things help us to connect to the other planes and connect SDN controller or control the SDN controllers, sort of. Okay. So these four planes of SDN architecture work together to enable centralized control and flexibility in network management and operations. These operations or the separation of planes actually allows for more efficient network management and also it helps us to improve the scalability and ability to introduce new services and applications with greater ease as well. So when actually I was when I started, I was telling about few protocols or tools and techniques that we actually needed for the implementation. That is one very important thing is open flow protocol. Open flow protocol is actually the key component of software-defined network that actually enables a communication between the planes in the network. Okay, it actually provides a standardized way of SDN controller to manage the behavior of network devices like communicating devices, say switches, routers, which all will help us in determining how traffic should be forwarded. Okay, so based on this open flow protocol, flow-based forwarding, centralized control, standardization, protocol messages, flexibility innovations, and all is very important constraints that we have to follow. So what is this flow-based forwarding? Flow-based forwarding is again a concept in forwarding network traffic, or how do we handle the network traffic based on flow entries defined by the SDN controller. A flow entry consists of matching criteria. Say we have these addresses and all, no, like source and destination addresses, ports, protocols, and its corresponding actions. Actions sort like forward, drop, or modify the packets or messages. All those things has to be considered. When a packet arrives at an open flow enabled switches, it is processed based on a flow entries installed by the controller. Now, how this controller manages is actually open centralized control acts as a brain of the network, which will help us to communicate the open flow enabled switch to determine how packet should be forwarded. Okay, so how packet should be forwarded. The centralized approach allows for dynamic and programmable network management in behavior to the real time based on changing conditions and its own respective policies. Okay, so the protocol messages of open flow, it actually helps us to define a set of messages which enhanced between or which is exchanged between the controller and the switches. This messages actually packet in, which is nothing but called as forwarding a packet to the controller for processing. Flow mode or flow mud, we say, modifying flow increase. Packet out is nothing but sending a packet from a controller to a specific port and so on. Okay, these messages enables the controller to exert fine-grained control over the behavior of the network. So the next thing is, or the very important concept in terms of switch, tools and techniques are open vSwitch. Or we call it as OVS. Okay, it is actually a multi-layer virtual switch that is designed to enable network automation and virtualization within the data center and cloud environment. Okay, it is actually a crucial component in SDN and is actually widely used in virtualized infrastructure. Okay, so rather than the actual infrastructure, when we go into this virtualization and cloud, this concept is being used, which we call it as open vSwitch. vSwitch is actually this virtual switch, we call it as. Okay. Now, what is this virtual switching? Virtual switching is a function of virtual switch, which provides a way to control VMs, which is nothing but virtual machines, and the containers within virtualized environment. Okay, so it operates at both layer 2 and layer 3. Hope you know what is layer 2 and layer 3 OSI model. It's actually nothing but data link layer and network layer. Okay? It is actually helps us to operate at both the layers, allowing it to handle a wide range of networking tasks within the virtualized infrastructure. So it is also offering a rich set of features like VLAN, VXLAN, GRE, STT, all are the supports of which helps us to enable the quality of services to access the control lists like ACLs, port mirroring, making all those things to be a versatile and a powerful tool for network administrators and operators. Okay. So you should also would have heard of hypervisors. Okay, this support of hypervisors in these open vSwitch is actually including KVM, XN, VMware, and Hyper-V. These are the set of listing hypervisor tools. I'm just repeating it again. KVM, Zen, VMware, and Hyper-V. These are all can be deployed across a wide range of virtualization platforms, providing a consistent network solution regardless of any underlying hypervisor technologies. Okay. So this open vSwitch is a versatile and powerful virtual switch that provides essential networking capabilities for virtualized environment. It supports for SDN integration with multiple hypervisors and rich features, which will help us to build any fundamental blocks of modern data centers and cloud deployments. So this is a wide usage we say, okay, which is used in most of the modern data centers and cloud deployments. So software-defined wide area networks and its own capabilities across different significant benefits are this will also help us to improve performance of the network, cost savings, increased agility. All such things are dwelling into these aspects. Okay. Now,
Doctor, you may speed up.
yeah, I can do that. Okay, improved performance both in dynamic path selection and cost savings. Okay, so these are the when it is in the concept of wide area network, improved performance, agilities, and cost savings is actually done with the help of SDNs. So network virtualization, if you see network, obviously everybody know that virtualization is a imaginary place to store your data. So those imaginary data and their architectures or the technologies are actually virtual local area network, we call it as VLAN, virtual extendable VXLAN, and routing, generic routing encapsulation is very important solution for this open flow and open vSwitch. These are the different solutions that we have to opt for a network virtualization. For cloud-based deployment, we actually wanted to deploy it in public, private, and hyper clouds. So based on the cloud deployment leverages, it also enhances the scalability and elasticity on demand nature of cloud computing and deliver network services and its applications based on either infrastructure as a service or platform as a service. Okay. Automated provisioning is what we actually do with respect to automated provisioning, streamlines the deployment and management of network resources through different different processes. Okay. So network function virtualization, it is a way to transform the network services are delivering by decoupling network functions from dedicated hardware applications and instead of deploying them as a software-based VFN, we call it as virtual network function, or industry standard servers, switches, and storages. Okay, so decoupling from physical hardware, agility and flexibility, rapid provisioning and scaling with cost reduction, virtualization technologies are a part of network function virtualization. So about our centralized control plane, network orchestration, and automated provisioning, we actually say that the centralized network control and management, the centralized control planes, network orchestration are very essential components of modern networking architecture. These concepts are enable unified management, programmability, and automation is done with all these sort of implementations. Okay. So, in detail about our dynamic resource allocation, self-healing networks are the way how protocols and topologies has to be created. Okay. So, like your normal network, SDN and deployment with its own technologies and tools are rapid deployment with the help of the defined tools. Okay. So, controls and panels, and these are the different applications that we work on. About the applications of different tools that I've discussed in detail. Okay, so these are the listed centralized planes and distributed controls. About centralized control planes, we actually say that it is actually helping us to simplify the overall management of the network that we create. A distributed plane, it is slightly challenging compared to centralized, but with the help of blockchain implementation in distributed plane, this also helps us to do it more securely. Okay, in terms of software implementations, it is again our a strategy in selecting which approach is best for the implementation that we work on. Okay. So this is all about the presentation. I'm open to answer any sort of questions that you can.
Thank you. Thank you, Dr. Priya.
Yes.
Thank you, Doc. Do we have any questions for Dr. Priya? You can post it in the chat, or you can raise your hand and we will acknowledge you. Anyone? Okay. Dr. Imran, I'm not seeing a question.
Okay. Okay, no question. Thank you. Again, Dr. Priya. So Dr. Comfort Olebara is here.
Yes, she is.
Can you hear me, doctor? Olebara, I cannot hear you. Doctor? I think she has some network problems. So we will go to the next presenter. I am muted. Okay. Doctor? Wait, maybe. Let me check. Dr. Krishna, can you hear me?
Yes, doctor. I can hear you.
Dr. Olebara is muted.
No, she can unmute herself. One second. Let me check. She is joined as. Let me check. Dr. Comfort, you're in what name of display?
He is here. Comfort Olebara. See.
I don't see her. One second.
Comfort C.
Comfort. Yeah. I'll try to remove her. Ask to unmute. I can only ask her to unmute. She has to unmute. Now, Professor Comfort, can you hear me? You have to unmute yourself, Dr. Comfort. I can only ask to unmute you. I have done.
Okay. We continue the next presenter because I think she has problem. Professor Dr. Pankaj Dadheech. He will present the current status of and the future of software-defined networks. Dr. Pankaj, can you hear me?
Yes, sir.
Okay. You may share your screen.
Okay, what is that? Yes, my screen is visible, sir.
Yes, yes.
All right, just
Okay.
let me give the bio. Yes, sure. Okay, Dr. Pankaj Dadheech is a distinguished professor in the Department of Computer Science and Engineering at Swami Keshvana Institute of Technology, Management, Gramotang, SKIT in Jaipur. Brings a wealth of experience and expertise to the table. With a proven track record in the technological landscape, Dr. Dadheech possesses extensive proficiency across a spectrum of domains, including SQL, C++, JavaScript, HTML, artificial intelligence, Microsoft SQL, among others. As a stalwart in the field, Dr. Dadheech continually strives to push the boundaries of knowledge and foster a culture of innovation with the academic community. Dr. Dadheech, we now turn over to you, sir.
Thank you. Thank you, Professor.
You're welcome.
So today I will discuss about the current status and the future of the software-defined network. So this is the outline. Already some have previous speakers discussed about SDN, some background, operating system for network, and I will discuss the current status and the future of SDN. So what is SDN? So already it is discussed that it is a network in which the control plane is physically separate from the data plane, and a single or logically centralized control plane controls several forwarding devices. So this is the SDN diagram. You can see the global network map is there where control programs are there and control plane and the data forwarding like this. So in the networking plane, there are three planes: data plane, control plane, and management plane. So in data plane, the processing and delivery of packets with local forwarding state. So forwarding state plus packet header to the forwarding decision, and the filtering, buffering, scheduling is there. In control plane, the computing the forwarding state in routers. So it determines how and where packets are forwarded, and routing, traffic engineering, or failure detection recovery is there. In management plane, configuring and tuning the networks or traffic engineering, SCI config device provisioning like this. So the time scales where the data is in packet nanosecond, and the control, the event is 10 millisecond to second, and management human minutes to hours. So the location for data is line card hardware, or for control the router software is there, and the management deals with the location humans or scripts. So data and control planes where the processor is dealing with the control plane, and the data plane dealing with the line cards. You can see in the switch fabric like this. So what are the challenges? So too many task-specific control mechanisms are there, no modularity, limited functionality is there, and indirect control. So it must invert protocol behavior, coax it to do what you want. So for example, changing weights instead of paths for the, so uncoordinated control is there where it cannot control which router updates first, and interacting protocols and mechanisms where routing, addressing, access control, and quality of service is there. So how SDN changes the network? So you can see the network operating system lies between the feature and the various machines where custom hardware, operating systems, features are there. So the in software-defined network, the first step is to open interface to packet forwarding, open flow. Packet forwarding takes place, and then at least one network operating system, probably many open and closed source are there in network operating system, and then in the control program where consistent, up-to-date global network view is there. So in network OS, the distributed system that creates a consistent, up-to-date network view, and it runs on servers, controllers in the network. So NOx, Onyx, Floodlight, Trema, Open Daylight, Hyperflow, Can-Do, Behave, Beacon, Maestro, and many more. So it uses forwarding abstraction to get the state information from forwarding elements and give control directives to forwarding elements. So in the control program operates on view of network. So input is the global network view where graph or databases are there, and for output, the configuration of each network device is there. So control program is not a distributed system. The abstraction hides details of distributed state. And forwarding abstraction, the purpose of this is to that standard way of defining forwarding state, so flexible and it is minimal. So a flexible where behavior is specified by control plane, and it is built from basic set of forwarding primitives. And for minimal, it is the streamlined for speed and low power, and control program not vendor specific. So open flow is an example of such as an abstraction. So you can see in software-defined network, virtual topology there, network hypervisor, global network view, and network operating systems, packet forwarding. So does SDN simplify the network? So abstraction doesn't eliminate complexity. So hypervisor are still complicated pieces of code. So SDN main achievements are it simplifies the interface for control program. It is user specific, and it pushes the complexity into reusable code, which is SDN platform, just like compiler. So why is SDN happening now? So the road to SDN is first active networking was there in 1990s. So first attempt back networks programmable and demultiplexing packets to software programs, network virtualization is there. And from 2003 to 2007, the control and data plane separation, where you can see the open interfaces between data and control plane, logically centralized control are there. So 4-phase, RCP, 4D, SAN, ethane, these are the main role for this control and data plane separation. And then open flow API and network from 2008. So the open flow switch interface is there, and NOx network operating system is there. So SDN drivers were rise of merchant switching silicon. So democratized switching and vendors eager to unseat incumbents. Then cloud and data centers, so operators face real network management problems and extremely cost conscious and desire a lot of control. So the right balance between vision and pragmatism. So open flow compatible with existing hardware. So a killer app like network virtualization. So virtualization is killer app for SDN. So consider a multi-tenant data center. We want to allow each tenant to specify virtual topology. So this defines their individual policies and requirements. So the data center network hypervisor compiles these virtual topologies into set of configurations, and it takes thousands of individual tenant virtual topologies. It computes configurations to implement all simultaneously. So this is what people are paying money for. So enabled by SDN ability to virtualize the network. So what are the practical challenges? The practical challenges are like scalability, reliability, response time, consistency, security, and interoperability. So scalability, decision elements responsible for many routers, for reliability, the surviving failures of decision elements and routers, response time delays between the decision elements and routers. Consistency means ensuring multiple decision elements behave consistently and the security is always there. So network vulnerable to attacks on decision elements and interoperability where legacy routers and neighboring domains are there. So what are the limitations of current networks? So enterprise networks are difficult to manage and new control requirements have arisen. So we want greater scale and migration of virtual machine systems, how to easily configure use network. So the limitations of current networks are many complex functions backed into infrastructure, millions of lines of source code are there, operating system features, billion of gates where specialized backend forwarding hardware, OSPF, BGP, multicast, differentiated services, traffic engineering, NAT, firewall. So cannot dynamically change according to network conditions. So another limitations are no control plane abstraction for the whole network, and it's the whole time was how this OS is look like. So an OS for network where network operating system places between control program and the various specified packet forwarding hardware and operating system apps are connected. So you can see the simple packet forwarding hardware is there. So this is the idea where network operating system towards an operating system for networks where software defined networking plays a role. So the protocols are here where the control via forwarding interface through the network operating system and global network view for control programs. So software defined networking where no longer designing distributed control protocols and much easier to write, verify, maintain. So this is the an interface for programming. Then network operating system serves as fundamental control block. So with a global view of network, so for example, Ethane, where network-wide access control are there, power management, then OpenFlow enabling the innovation in campus networks like hardware drives, drivers like interface between switches and network operating system. So you can see the OpenFlow controller where secure socket layer and transmission control protocol, how it communicates with the control path and data path hardware. So for OpenFlow switching, the software layer is there and the controller is controlling all these things and hardware layer includes the OpenFlow table and the systems are enclosed. So the rule action in states are there. So the rule where the switch ports and MAC and then Ethernet type, TCP port, these IP port, DHT, synchronization, everything is there. So action where forward packets to port and encapsulate and forward to controller and drop packet, then send to normal processing pipeline and states where packet plus byte counters are there. So centralized versus distributed control where you can see a distributed control platform for large scale production networks and the centralized control where the controller is central role between all these OpenFlow switch. So the current status of SDN where hardware support, Juniper MX series, NEC IP 8800, WiMAX is there, HP Procure, Netgear, PC engines, Pronto, Sina, Co redirector, and many more are also in the pipeline. For industry support, the Google built hardware and software based on the OpenFlow protocol, and VMware purchased Visira, and IBM, HP, NEC, Cisco, and Juniper also are offering SDN that may incorporate OpenFlow, but also have other elements that are specific to that vendor and their game. So the future of SDN. So you can see the market looks promising, driven by the need for scalable and secure network infrastructure. So as organizations seek cost-effective solutions, SDN, software-defined networking, offers the potential for substantial saving through optimized resource utilization and simplified network management. So additionally, its ability to centrally enforce security policies enhances overall network protection and combating the ever-growing cybersecurity threats in the internet. So innovation is the key to the software-defined network market success. As the technology gains momentum, vendors are likely to invest in research and development, leading to cutting-edge SDN solutions. So the competition will intensify, stimulating the creation of more sophisticated and advanced software defined network products. So this ever evolving landscape ensures that software-defined network remains at the forefront of network architecture, meeting the dynamic needs of modern business. So the journey of SDN future is contingent on external factors such as industry regulations, economic trends, and the emergence of alternative networking technologies. Monitoring these shifts will be crucial for businesses and decision makers to adapt their strategies to increase the full potential of SDN and stay ahead in an increasingly connected and digitally driven world. So this is all from my side. Anyone have questions? I am happy to answer.
Thank you, doctor. Any questions?
I'm not seeing any in the chat. You can post your questions in the chat, or you can raise your hand and you will be acknowledged. We're not seeing a question, doctor.
Thank you very much. I think doctor is not in the meeting, I think, anymore.
That's Dr.
Dr. Comfort.
Yes, she's here.
Can you hear me? Dr. Comfort. Are you here? Yeah, can you hear us?
Camera.
Oh, thank you. I'm grateful. Thanks for your patience. Give me 1 minute, please.
Okay. Dear participant, meanwhile, I shared a form. You can fill these forms and get the certificate of attendance. I already sent in the chat the link.
Yeah, good day. Thank you so
I
much
think
for your patience.
Dr. Comfort is there.
My camera
Yes.
had issues. I've just been working on it somehow. Thank you so much for your patience.
You can share your screen, Dr. Comfort.
I will right away.
In the meantime, I'll just go ahead and give the bio.
Okay.
Dr. Comfort Olebara is a distinguished senior lecturer of computer science at IMO States, University of Nigeria, boasting over 12 years of dedicated teaching experience. Holding a Doctor of Philosophy degree in computer science, she exhibits a profound expertise in various domains within the field. Her research interest encompasses a diverse range of cutting-edge topics, including the Internet of Things, IoT, cybersecurity, hardware backdoors, and computer constructions. Dr. Olebara's extensive knowledge and research contribution in these areas undoubtedly enrich both her teaching and her scholarly endeavors. Dr. Olebara is knowledgeable and proficient in discussing this topic, which is software-defined networking, a dynamic and transformative approach to network architecture. Dr. Olebara, our last presenter, are you ready?
Yeah, ma'am, I'm ready. Thank you so much for your patience. Thank you. I'm grateful. I'll be discussing the evolution of network management and a little bit of our software-defined network. My other presenters have actually done a good job in this area of software-defined network. So I'll simply go through the area that I felt I really worked on more. I wanted to introduce computer networks for enterprises because in this time, post-COVID, many enterprises are moving to the cloud. Many enterprises are looking on ways of improving their services. Before the COVID era, we had people still comfortable with the traditional networking system. But during the COVID, many companies, enterprises moved to the cloud, many moved to better ways of doing business. So enterprises kind of have the LAN network for their offices and their single buildings, then the one spanning countries, spanning cities, and so on. Then moving ahead from the to the software-defined one, which we know is the same one architecture, but now defined using virtual components, virtual infrastructure, unlike the routers that are physical switches. We are now talking about virtual components. Most of these enterprises cannot afford the kind of, or the level of infrastructure needed in the one. So they kind of go to the third-party service providers, and then who kind of give them what we call network as a service. Now we have also the cloud networks, which has to do with one infrastructure delivered by third-party cloud service providers. My work is basically on network management. The SD1, or the software-defined network, is simply an abstraction from the physical system. And in this system, we have, like others have already said, separation of the data plane, the management plane, and the control plane. And by the control plane, now we are talking about the controller. So I want to look at the management in the area of process monitoring, optimization, security. These are the things that make up management. And then the computer networks also are there to ensure availability of service and reliability and security as well. So I won't take your time really. I just want to run with my major work. Our nodes in the system are like linked lines, which could be wired or wireless lines that connect endpoints. And we have the protocols that work in these different layers. We have the OSI 7-layer model, then up to recent time, we now have the TCP IP model, which kind of brings some of the layers in the OSI model and then puts them together. So we now have the evolution of management, computer network management, starting from the pre 1980, we have where the ARPANET came out between in the mid 1970s. Manual devices were configured manually, like the physical devices were configured using manual methods. And then analysis then were kind of reactive. You encounter an error before you try to fix it. There's a network failure, you now want to fix the network failure. So that was the method used for problem resolution. Then between 1980 and 1990s, we had the simple network management protocols, which were used for remote monitoring. Then up now again to 1990s to present, we still have the fault management, the configuration management, the accounts management, performance management, and then the security management, integrated together to make up what is called the FCAPS protocol. So this came in around 1990s and is still in use to an extent. Now, between 1990 to 2000s, we had the graphical user interface-based network management, where applications are now used, and then visual interfaces can be used to monitor. But in this, at this time, most of the applications were vendor-centric. Like for Cisco, if you want to use Cisco routers, you really need to know how to configure Cisco using their APIs. You need to know how their configurations work and all that. So the graphical user interfaces came up solving some of the problems that the CLI, that's command line interfaces, had, but yet being vendor-centric. So up again to 2003 to still present, we had network management platforms which are vendor neutral. Vendor neutral in the sense that a particular vendor, maybe the router may come from Cisco, another company will be having the switches and so on. Then a common platform can be used to manage all the components in the network. So there in this 2023 to present, we had the network management platforms, neutral, vendor neutral ones. Now coming up to 2010, entered our SDN, the software defined network, where automation came in, and automation from a central controller. The previously hosted control plane, which was in the device, we are now brought into an interface. We are now brought into an application, and then that's what we now presently call the controller. It is the same control plane that was in the individual components, individual switches and routers, that was now separated and then called the controller. So the controller now interacts directly with lower level applications, which is the data plane and also the application plane. So I'm not going to dwell much on this because a lot has been said and all in the right order. So 2010 ushered in SDN, and it's still in use. But we have actually kind of gone beyond the regular SDN. SDN architecture is still in use, but now we are talking AI, we are talking subsets of AI, we are talking cloud-based management of the network. So that's analytics and management using data that has been produced already, because our enterprises produce a lot of data, and use the utilization of this in gaining insight into management, into predicting failures, is what actually gives life to the enterprises. Because the goal of every enterprise is to ensure network continuity and to ensure content continuity. Because downtime as a result of network failure will amount to a whole lot of financial loss to the enterprises. So components of network management, we have many of them. Data analytics is there, which is actually the most important. You have to talk about the device configuration, endpoint connectivity, login system, network automation, server connectivity, switch, and all the, analytics is at the center of it all. The use of produced data in predicting and creating baselines, and then being able to predict a system, and also giving alerts when such baselines are kind of encountered, like when there's an abuse in a set baseline. So prior to COVID era, we had this kind of connection where in our traditional network connectivity, MPLS, which is the multi protocol layer switching, was used as the primary connection, while the internet came as secondary. Then we have IPsec VPNs that we are used to tunnel between data centers and branches. Then we had firewalls and acting as security points. And also we have the physical routers, switches, WAN optimizers, and dynamic multi-point VPNs playing here. For our connection, when we talk about the enterprise data, we're looking at the LAN first, because actually the LAN formed the first networks, and then from the LAN we now move up to the WAN. So the LAN is actually at the layer 2, where you have the switches working at OSI model layer 2, then connecting up to the routers, which, because through the LAN you have the switches, and then through the routers you can link up to the internet. So, and our MPLS works at the layer 2.5. That's between this layer 2 and layer 3, because layer 3 is our network layer, where we actually talk about routers connecting us to the internet. But our MPLS work between the second layer and the third layer. Now, the MPLS actually is kind of the network management system, the packets management system. It produces the labels through which the packets are known and managed. So each label or each packet has about a stack that has 4 parts. We have the first parts talking about the label value, which actually tells us the next destination of the packets. And then we have the traffic class field, which sets our QoS as quality of service, priorities, and congestion control information. Then we have the bottom of the stack, which indicates the last label on the stack. Each one has the number of bits it absorbs. And then finally, we have the time to live, which indicates the number of hops before data is discarded. And that's the lifetime span of the data. Now, at the MPLS, data comes into what we call the ingress. The ingress is like the label edge router. That's routers at the edge of the network. That's through which the points through which the packets come into a network. So from the ingress, it traverses the network, and then it is guided through the label on it. Each packet has a label placed on it, and from that label, the destination is known. So other routers, like label switching routers that are on its path, will, based on the information that it contains, guide it towards the last router. Okay. Guide it towards the last router, which is our egress. The first one is the ingress, then we have the egress, where which forms the last point, the last router before the destination proper. So at that egress point is where the label is finally dropped, and then IP routing will now be used to deliver the packets to its destination. So this is actually the contemporary traditional network system, where we have the 3 planes: management, data, and control planes, all built inside the network equipment or device. So moving on to our software-defined network, we already have talked about this. I've heard this discussed already, so I won't dwell on it. To have the application layer, control layer, and the infrastructure layer.
Doctor, you may summarize it because we are already out of time.
Okay, so okay, let me throw lights where I have interest today. I'm looking at the management of a network. So on this management level, the main goal is achieving high throughputs, ensuring that there's network continuity, there's content continuity, and there's security as well. So there are steps towards having a steady or a comfortable management system, because in this era, you're not going to build your own management system from scratch, but this is just a guide for you to know what to demand from the management system or the third-party management system vendor you are trying to get onto. So you have to have one that is able to collect data, every form of data, vendor-specific data from every kind of protocol. So you won't be limited to being able to collect some types of data and not collect some. Also, maintenance of collected data should be at least 1 year. Every data collected should be able to be, you should be able to pull your data for minimum of 1 year, not a service provider or network management service provider that will kind of average your historical data because of storage limitations. So you should be able to have a learning system using machine learning. Automated learning systems help you carry out analytics that give you insight into planning. Now, your learning system should be able to give a baseline as to what defines a normal performance. And then the normal performance should be able to compare network performances like every 15 minutes, multiple times in a day, so that you know when something is going wrong and you'll be able to fix it before it gets out of hand. Then identify deviations and set alert methods. Alert methods can be 2 types. We have alerts based on thresholds on CPU utilization and alerts based on deviations from machine learning baselines. So your network management system also should be able to give you reports, and these reports should be reusable, like reports that can form templates for future report building. So it's not like you got reports today and next time you need to build from scratch. No, it should also be able to give you a visual view of related metrics, flow and alert data and troubleshoot workflows also. So these are some of the things to expect from your network management system. Then the analysis also should be able to detect where there is void performance, that's to be able to avoid performance problems before they occur. By this, I mean that there should be kind of proactive response to problems encountered, not reactive. Reactive, like when the problems happen, you start fixing them. No, the analysis system should be able to predict faults and be able to fix those faults before they occur to avoid downtime. So finally, you should be able to share your insights, because the purpose of carrying analytics is to gain deep insights and then to work with the insights. So you should be able to share your insights with co-workers, with the management, and to help them make informed decisions. Thank you very much. I think I'll call it.
Thank you, Dr. Olebara.
I think no sound. Maybe there is a connection problem.
Okay.
Okay. Doctor, can you hear us? Comfort Olebara?
I think she's having a connection.
I think it's a connection. Yes, she already finished. So thanks everybody for attending this seminar. It's really beneficial. We have seen the developments in technology and in the networking. The development also is growing. I mean, the standardization, having central networking or open networks will improve the connection and the traffic of the data. Is clear, and this step will go further with these standard protocols and with the new methods. So it's really very beneficial, and we will see in the future probably these developments more. Dr. Krishna, you want to say anything, or anybody have any question to Dr. Olebara? Krishna, I cannot hear you. Doctor?
Yeah, I'm here.
Okay, we can hear you now.
Yeah, Dr. Comfort, are you going to continue?
I'm back. I'm here, sir.
Okay, Dr. Comfort, can you hear us? I think there was a connection problem.
Yes, I can hear you.
Thank you for the nice presentation.
Thank you, sir.
Any questions?
So then
or any
we close this.
contribution?
Yeah.
No, Dr. Krishna, you want to say, you may summarize, you give some,
Yeah.
you are an expert in this
Yeah.
networking
I
and
have,
digital technologies.
No. I'm happy with the work done by Sherry and Earl from the University of West Indies, and I'm equally thankful to Dr. Imran for having conducted this workshop. Though we had some slight issues in network during Dr. Comfort's presentation, we will try to share this presentation to the participants so that they also get benefited out of this. Thank you all.
Thank you very much. No questions. Please
Thank
don't fill the form. You can fill the form and get the certificate of attendance. I think everybody can see this form, right?
Yeah. Yes.
If no question, I will finish the workshop. And I want to thank Dr. Krishna, Sherry, and Early, all the presenter. We have a good time. We have learned new things, and we are happy to see this development in the networking. Hopefully, the security problems also will be solved. As we know, this centralized and these open networks, they have a very huge security problems. But the cost, the scalability, and the advantages of networking will bring new benefits also. So the advantages, disadvantages. Thank you very much. If no any question, we will finish this workshop.
Thank you, Doctor. Thank you, Doctor.
Okay.
Thank you,
Okay.
Sherry Ann. Thank you. Bye.
Thank you too. Bye-bye.
You're welcome.